now, when we drop it in water, what do you think is going to happen? But come over here so you can see what it looks like. Because you can see it's kind of dark right now. We're going to cut it, and you notice how it is shiny.
Oh, yeah.
Like a metal. Last one. Now what happens?
They're like dissolving.
Alright, so go write down your observations. What happened? Now try to move on to sodium and write what you think is going to happen when we drop sodium into the water. Here's our sodium.
What is it, like salt?
So salt is made of sodium. It's sodium chloride. So it's sodium and chlorine like have combined together.
Oh.
So this is like
hard?
yeah. So this is a metal, right?
Oh, these are all metals?
Yeah, these are all metals.
Oh, it turned into a ball.
Well, smoke.
When you're doing chemical reactions, it also depends how much you're putting into it, right?
Oh, yeah.
This one we are actually gonna go outside to do. Dante, you haven't done it?
No, I haven't.
Okay, grab that piece. We're gonna head outside.
It's gonna be really hot. He like jumped away.
That's on fire. He was right. Oh, that was it.
Yeah, it. Was the reaction fast or slow?
You should have let me put in the
It was
big
pretty
piece.
fast, right? No, then we might not have a glass beaker at the end of this. It might be gone. Now the other ones, we don't have those metals because what do you think is going to happen with the as we keep going down our periodic table?
It's gonna be bigger.
Yeah, and like I said, we want to keep our glass beakers. We don't want to drop metals in there and then have actual explosions happen.
Elements
Wait,
in group
Miss
1.
Molina, are you talking about all the ones here?
Like group 1.
Yeah, so these are all the ones that
Yeah,
we
they all
did.
exploded. Oh, why?
Like not what they did, but why did they react that way?
Oh.
And the hint is because they're all in group 1.
They have more energy as you go down the periodic table.
Because they're different.
Yeah, because as you go down, you have more energy levels, and so
Just
like
those 4 questions.
if
Yeah,
with
just those
lithium,
four we'll talk
once
about.
you got rid of that valence electron, you only have 2 electrons. But as you go down further, you end up with like 8.
So number one, why did all the elements in group 1 react similarly with water? So they all kind of fizzed, bubbled, exploded, things like that, right? What do they all have in common? Yeah, Rachel.
They want to get rid of 1 electron.
Yeah, so they are all here in group 1A, which means they have 1 outer electron, which means to get to 8, they're going to lose an electron to get there. So what's different on my periodic table as we go down our group? Yes, no?
They have different number of rings around them.
Yeah, perfect. So they have different number of rings. Before we did this lab, in our notes, we said that if you can lose an electron faster, you're going to have a more explosive or faster reaction. So who can lose an electron faster, lithium or cesium? Cesium, right? And why can cesium? So cesium has more what around it? Rings. So the electron is really far from our protons. So can it be attracted in very well by our protons? No. So when someone comes to try to take it, can they take it pretty easily?
No.
Yeah.
Oh,
Yeah,
yes.
right? Because it's really far away from what's trying to pull it in, right? So as we add in those rings, and we're in group 1, adding in those rings makes that electron far away, making it really easy to take. And so it's going to be more and more reactive as we go down and add those rings.